The agenda, or the way how I want to do it in this talk, is that we will have an application which uses already signals, and we will do a refactoring towards the signal store, and we are introducing its features step by step, I would say. But first, a little bit of a theory, why you want to use the signal store and why is it actually necessary. I have 4 reasons for you. So the first one is, when it comes to the signal store, I mean, it's a state management tool, and it's a very special one because the state internally is a signal. So it's not like some different data structure that the signal store has, but it's really, the state is a signal itself. Which means we have some advantages, especially if you are a developer of the signal store, because you inherit all the functionalities. And for us developers, all the rules that come already with signals. So we have those kind of reactivity, we have the glitch-free effect, we have the immutability, the requirement for immutability, and also the derived values, the computed. So this is something you don't need to reinvent because signals give it already to you. The other reason is, I mean, we have seen before in Alan's talk that signals are very simple to use. We have just 3 functions, not more, very easy. But nevertheless, if you have larger values that you want to store in a single signal, then you very soon hit some kind of boundaries. So you will see them later on what I mean. But you need a little bit, you need more function in order to manage those kind of signals. And this is exactly what the signal store gives you. It's also a structured approach. This is something which I really like from the NgRx global store, the old one, that it kind of enforces a certain structure. The code is organized. And if you're entering a project and you have no idea what this kind of code looks like, then the signal store at least a little bit says, okay, this is the place where the methods go, this is the place where the derived values, the computed go, and this is the place where the state has to go. So there is a little bit of structure there already, which is also very nice. And the main benefit, I would say, and this is even to me personally, that's the reason why I would favor it over this global store, is its extensibility. So you can very easily come up with your own extensions that you can then apply to other different signal stores. Good. As the Angular signal itself, the signal store or NgRx signals is mainly consists of functions. They also call it sometimes standalone functions, some of them. And you see here in this illustration, again, everything is based on the Angular signal. So this is where we start. And then we have 2 functions which are called patch state and rx method. These are functions where you don't necessarily require the signal store. There is also a lightweight, I would say it's between a signal and the signal store. That's the signal state. And you can use the patch state with the signal state together. And rx method is something you can even use without the signal store. But of course, we will take a look at that one later. And the signal store itself is a function, but it comes together with all these other functions, which you see here in this green rectangle. So with methods, with state, we will go over all of them. And yeah, so you can, in a way, like kind of build your store step by step by adding one function after the other. That's the basic idea. Good. So I would say let's take a look at the application. I said before we want to do a refactoring. So the application, this is StreamYard. This is the application. This is my usual application, which I use most of the time. So we have here some kind of holidays, and it's coincidence there is now a holiday for Poland. And the nice thing is that this holiday has some kind of a quiz. So we have here like what's the national dish, what's the currency used, and so on and so forth. So a basic quiz, more or less. I can click on some answers here, and as you see, there are some additional functions. So whenever I click on an answer, it says if it's correct or incorrect. And we also have here something like a countdown. So I only have 3 minutes time to finish here this quiz. So and this is where we are focusing on. If we take a look at the code, then we see that this is here the quiz component. I hope nobody complains that I'm using the light mode. Last time somebody said I can't look at it, I should use the dark mode, but then I'm getting blind. So yeah, I hope that's fine. But yeah, in the end, this here is the quiz component. It has, of course, a lot of HTML, as we see here. And we also have here quite a lot of TypeScript. So as I said before, this is all based already on signals. So we have here a huge signal, actually, which is the quiz signal. It contains the title, the questions, and also the time in seconds. And based on that quiz signal, we need to come up with derived signals, namely for questions, title, and time in seconds. So those are derived signals. Why do I need them? Well, because they are used in different parts of my component. So, I mean, it could also be a little bit different, where maybe I would say this component, I want to split it up into multiple subcomponents, and then maybe one subcomponent gets the questions, the other one gets the time in seconds, and so on and so forth. The main point here is that I have the need to take one huge signal and split it up into multiple pieces. This is what we have here. What else? We have here the status. This is the one that shows me how many questions I have already answered. This is computed, so a normal signal. Nothing very fancy. Then we have here an effect. So we are working here with an input property where I'm getting the ID for that particular holiday. And from there, I use the ID to get the questions. Then I have here my countdown. This is done here with rxjs with an interval. And then last but not least, we also have here the answer function. I mean, it's not important what is inside of the function. It's just important that we have those kind of elements. But there is, of course, a function when I click on the answer that decides if it is correct or incorrect. Good. And the goal now is that I take all the TypeScript code. I will leave the template in the component. This is where it should belong to. But I want to now refactor this component and extract this code into the SignalStore. And we will start with the basic functions. And these are the SignalStore itself, which contains a certain state, and the two functions that allow me to read and to write data from my SignalStore. Good. So what do I have to do? Well, first of all, I have to select the values for my state. And as I said before, everything derives from this quiz here. So I take here this object literal, or that I have, and I'm going to create my quiz store in a separate file here. The way how it works, you say SignalStore. It's just a normal function. And inside of this function, you can now start to add your features. And the first feature is the state feature. So we need to have some kind of container where we can store our data. And that's the function for that is with state. And this is where I'm putting my values first, my initial value. I also need to type it a little bit because with an empty array, we are not getting very far. Otherwise, it's a never, never. And I also now need to do something with the value which is returned here. And the SignalStore returns me the class. It returns me a class. And that's why I'm not saying quiz store with lower capital, but I have to start it with uppercase. Because it looks a little bit unfamiliar, but this quiz store is not an instance of the SignalStore. It is a class. So it has to be instantiated. It's not instantiated yet. Instantiation works now via the Angular's dependency injection. So I could here say I want to have the quiz store as a service which is provided globally. But I could also say I want to go with local state management. This is what I'm doing here, which means my component needs to provide it. So I say here, as I would do with any other service, I would say here, I want to, I also think I also need to export it. I need to provide here the quiz store. Good. That's the first step. Now I need to inject it. Quiz store, not quiz service. And the question is now, what do we get now? What does the quiz store return me? If we go into the constructor, then we can see what this is all about. So if I say here quiz store, then we see that it all of a sudden contains the 3 properties that are already in my state as, it looks like as normal properties. But that's not true. I don't get here an array of questions. I don't get a string of a title, but these properties, they are slices. So they are already signals, which means if I have already a signal for questions, title, and time in seconds, then I don't need to create them manually anymore. I can just assign them here to these variables. So I can say, well, I don't need to compute it. The computation has already happened. I just need to say quiz store and give me the questions. I mean, it didn't happen. It happens the first time that I access it. It's generated on demand, but let's just say those signals are already available. Now I can do the same thing then also for the other points. So I could say here, yes, quiz store. I just want to access title, time in seconds. And you see here that IntelliJ immediately understands that this is now of type signal, question array, signal of a string, and signal of type number. So this is this kind of reading part, which I get for free. I just need to put the value into a signal store, and I have those slices. They are also nested. So if I would have here some kind of an object literal, which again has an object literal, then I can go into it, and I would also get a signal from those nested objects. Reading is not all. We also need to be able to write to a signal. And in order to write to a signal, we see already that there is now a little bit of a problem. Not really, because here now we have a problem, because here it says, well, quiz set is not available. Now, of course, it's not available. I've just removed it. But when I want to set the data, I can't set it. The signal store itself doesn't have a set and doesn't have an update method. What we have instead is that we have a patch function, because we say, yeah, with a normal signal, I would say update, I could say set, I could provide all the complete value all the time. But with a larger object literal, very likely I only want to update parts of my signal, not the complete value. So I want to patch it. And this is also what we get here. We have a patch function instead. The patch function is a standalone function. So I have to say patch state. And I can say here, okay, this is the store that I want to update, and I want to write now the quiz data into it. This is everything which is necessary. I mean, at the moment, I'm using patch state to override the complete value, but I can also do it for partial values. Partial values are used here in this answer, because the answer method only updates the questions. And we see here that this kind of immutable function needs to clone the current quiz, and then it just adds here the new questions. And here I can say, I don't need to clone it. I just say that I want to update the questions, and the rest of my quiz store should stay as it is. I don't want to touch it. I don't even want to know what's inside of it. So what do I do? Well, I say again, patch state, and I say this quiz store. And then I say, I want to update now the questions, which means I take this part here, this questions map, I copy it here. And of course, quiz does not exist anymore. We know this already. So I say here, quiz store questions. It's a signal. We know this already. I'll run the map. And I don't need to care about this cloning feature here anymore. And I am almost done. So we can go back now to my application and see if it's still working. Yeah. So reload. Yeah. Take a wrong one. Yes. Yeah. Counter is working. Status is also working. Data is also there. Everything works. So this was the reading and the writing part. Very easy. Slices and patch state. The next one is this kind of structural part where I said this signal store requires or forces me to structure my code in a certain way. Which usually with large signals, we also have the requirement to add logic, obviously. And there is a certain place where the signal store says, this is where you have to put your methods. This is where you have to put your logic. And this comes with the method with methods, obviously. Question, do we have somewhere a logic? Yes, I would say answer is already a logic part, and I don't want to have this inside of my component. I want to move it to my SignalStore. So I copy it, I cut it out, then I go to my quiz store, and instead of saying now with state, I just say, okay, I have now something else. I have those methods which I want to add to my quiz store, and what with methods is now doing, that it expects from me, it gives me, first of all, it expects from me a function, and in this function, it gives me the current store. So I could, inside of this function, access my properties of my state if I want to. What is expected from me is that I'm returning an object literal where all the properties are methods, which should then be added to my quiz store. Well, and at the moment, I just have one method. I only have this answer method. So I say, okay, then I just return something. I return an object literal, which is answer, and copy this function into it, which I have now taken out from my component. We see already here some errors. That's obvious because this questions does not exist. We are now inside of the quiz store, but I can just very easily say, okay, we have access to the store here. So I just need to replace this. And here again, just say, okay, just go with the store, and then everybody should be happy. It's just a simple copy and paste what I've done. We are not done yet. First of all, the question is, how does this answer method now look to the outside? Again, constructor, quiz store, and we see now immediately next to my slices, I'm now getting this answer method, which has the same signature as the other one, and I can now use it right away. I'm going to use this answer method directly in the template, because I don't think I need to come up here with a special event handler. Of course, you could do something like handle answer, and then you internally just call quiz store answer. But yeah, I think that's acceptable if I do it here directly in the template. Good. Do I have some other logic? Yes, there is something else, which is the loading part. So we have here quiz service find by ID. And this is something I also want to now extract into my SignalStore. So I say, okay, I have here a load method. This will be an asynchronous task. So I can also say here async. We've heard before that maybe we don't want to use rxjs all the time. So we have a comeback of the async await. And I say I have a quiz ID of type number. And well, now I need to get access to my quiz service, which is fetching me all the data. The problem now is, how can I here access the dependency injection? Unfortunately, I can't do it here, but I have to do it before my with method returns something. So in this space here, the code in this space here is executed in the injection context. So I can very easily say here, yes, before everything starts, now is the time that I say, hey, look, I want to have access to the quiz service. And you see already, there are some discussions about inject versus constructor function. I would not be able to use the constructor here because there is no class. There is no class inside. It's all just functions. So without the inject, that wouldn't even have been possible to do something like this. Good. We have here a task to do. So I say here quiz service find by ID. I say here, yeah, this is the quiz ID. Well, I can say, wait, this one returns me already a promise. And well, I just use the patch state function in the same way as I've done it before in my component. So I say patch state. Access to the store is there. It's just a store. I can use the await here as well. And well, that should be it almost. Of course, I also need to update my component. I always wait a little bit if the compiler here at the very bottom doesn't show me any error messages. Looks good so far. And yeah, inside of my effect, I need to change now a little bit. I need to say, okay, maybe I say here quiz service, not quiz service, just quiz store. Quiz store. No, load. And I say this ID, just call it. And I could leave the untracked if I want to. We will see if it works or not. So I'm just doing this in my effect. Good, wonderful. Data's there. Countdown is shown. Functions of the answer function is still working. Great. So we have now moved all the methods to this kind of logic, the answer and the loading logic into my signal store. So the component gets more and more or less TypeScript code. Good. Next thing. Next to the logic, we of course also have the demand for derived values. So I need to find a way how I can add my computeds into the signal store. And no wonder there's a function for it as well. And this is the third major function next to with state methods. It's called with computed. And with computed is very simple because, as I said before, the signal store contains the state already as a signal. So it doesn't have to reinvent the wheel. We can just use the computed function from Angular itself. Question is, do we have something somewhere, something which can be computed? Yeah, the status looks like a good candidate. Here we have a little bit of complicated computed. So let's just copy that one, go back to my quiz store. And well, here I can say after with methods, I have a new with function. This time it's with computed, works in the same way as with methods. It gives me the state and it expects from me, from my function, that it returns an object literal containing properties which are generated by computed. So I say, okay, I have here my state and I'm going to return an object literal, and this object literal contains only a status property, which is using computed. And of course, you also have to change here again. This does not work anymore. So I access here state questions, and that's it. That's it. Yeah. So very simple. With methods was a little bit more complicated with async await, with the injection context and all that stuff. But here with computed is, I would say, very straightforward. And in the same way as we had the load method and the answer method, my quiz store in the component also gets now access to the status. So once again, let me take a look. Quiz store, we have here the status. This is now this kind of signal, this computed signal which we have. And I'd say I use it again directly in the template. So I don't create here an artificial property. I just use it here directly from the template. So I say here quiz store, just access the status, and I'm done. Yeah, we can already start to remove things. So the quiz service is not required anymore. And now it starts to become a little bit more interesting. But let's quickly summarize, because what we have seen so far are the basic things. So we can manage the state with state. We add the logic with methods. And for the derived values, we use the with computed. In order to read data, we get the slices, just normal signals. And in order to write data, we have this patch state function. That's it. Very simple. Good. What comes next is rxjs. So in some cases, we might want to use rxjs for certain tasks. There was a question before, when should we use rxjs? When should we use signals? Yeah, I would say use signals as long as you can. So I have the same opinion as Ella, and I think everybody else from us also shares my opinion. But with Rx method, I have the possibility to use rxjs in a very good way. Let's put it like this. Do we have a use case for it? Let's maybe ignore the interval for now. This comes later. Let's just say here with the loading thing. So when my ID changes very often, then of course I have a problem, because now multiple HTTP requests would be triggered, and I want to use rxjs for that to manage it. So I say, just in order, or just in case this ID is kind of switches or changes its value 3 times, I want to use a switch map for the HTTP request, because I want that when a new ID value comes in, that my request, the former one, is canceled. Now, this is something which is very easy with rxjs. So how do we do this? there is this Rx method, which we can now use in order to generate a new method. So I call this here, that's the old one, that's the underscore load. And I now create a new load method. And I can now use Rx method. Careful now, because this is a little bit complicated if you see it the first time. Rx method is a factory function. So it's a function that generates me another function. And I can now say what kind of parameter, what type the parameter of this function should have. And I say, well, the load method does already have a quiz ID, is of type number. So I want that my new load also has its first parameter as type number. Very easy. And to the outside, this load method, what that we have here, looks like a function which expects now a parameter of type number. But internally, for the implementation, Rx method deals with every function call like an observable has emitted a value. So for me, to the inside, I could now say I have here a pipe method. So I could pipe to the function calls, and I could then treat those function calls as if an observable of type number would have emitted a value. Again, if I in my component would say load 1, load 2, load 3, then this pipe, this observable which I have here, would emit 3 times those numbers. And I can now use the normal rxjs operators, for example, the switch map, in order to control those multiple events. That's now a perfect use case for rxjs. So I say here, I have my switch map, and the switch map gets the ID. You see here already, ID is of type number. So type inference works perfectly. And I say, okay, quiz service, do now this find by ID here as well. The switch map also knows how to deal with promises. It's not only about observables. And once I'm done with it, I have a tab operator. I have a side effect in that case, where I say, well, I have now my quiz data, and I want to now update my state. So I say here patch state, store, and add the quiz. And that's it. Of course, there's also another one. There's a tab response, but let's not complicate things. The point here is I can now call the function as often as I want to. Internally, I'm dealing with it as I would have done it with any other observable. Which means actually to the outside, nothing has changed, because here the quiz store load still calls load with a type of number, and that's correct. Why not? This is exactly what I have defined. I said the Rx method should have of type number. So if I now go back to my application and reload it, I go to holidays. It's a little bit slow. It's very slow. Hope there are no errors. No, we are here. Yeah, right. It's working. Counter is also running. Give me back my DevTools. So, you might not say, okay, that's cool, because I can now control those events with the switch map, but I can do even more. Because this Rx method doesn't just generate me a function which expects a number, it also is now a function which would accept an observable of type number or a signal of type number. Which means I have here actually a signal of type number. Well, I don't need the effect for it, because I could say quiz store load, and I just provide here this ID. I'm not calling the signal. I just provide the signal as it is. The Rx method is now smart enough to understand that this ID is now a reactive type, and it would re-execute, or the internal observable would emit every time where the signal also triggers a change. So in this case, the effect is not necessary anymore. Everything is taken care of by this Rx method. Unsubscription is also not a problem. The SignalStore takes care of it. Now let's see if it works. So I go back, I reload it, yeah, counter runs, wrong answer, perfectly, everything works correctly. Good. So this was the easy one. The easy was the NgRx method. We still have another one. We have the interval, we have the countdown, because I also want to implement the countdown with the Rx method. That's a perfect fit because I have here already an interval. There is already an observable there. So why not combine it with Rx method? What this one is doing, it says, well, every time, every second in this case, it is updating in my this time left signal. And it says, yeah, the way how I countdown works. I think I don't need to explain it to you. So what I want to do now is that first of all, I want to create now a method in my SignalStore that updates the time left. And then I want to use the interval in combination with the Rx method in order to call the update time left method every second. This is my goal. So what do I do? What do I have to do? Well, first of all, there are some additional properties that I have to add. I have to add here time started, time left, and time in seconds. They also are now, time in seconds is already in my SignalStore. So I say here time left is 0 and time started, I think, is a new date. So we start with now, time started, right? So now we have that in our state. And then, as I said before, I say here update time left. It's a normal method, so we don't need Rx method for that now. And, or let's just use Rx method. Let's shorten things. So I say here Rx method. I say, I actually don't care what you give me. It's just important that you can call me. So I say here unknown. And every time I'm being called, I will just use here again a tab where I say pipe tab. Careful, where I say I'm now doing the recalculation of the uptime of the time left signal. So I can go here. Now I can say, okay, this function that we have here, this time in seconds, gets now into my tab one. So here I say patch state. I have access to my store. And then I say, I want to update the time left and only that. And I don't care about the rest anymore. So I say here store and here also store. And this is what I want to do. Okay, so to the outside again, update time left is now a simple function which expects an unknown parameter. So I just need to call it and that's it. And I use this Rx method, this update time left now, to provide not a signal, but the other reactive type that we have, namely an observable coming from the interval. So I just say here, okay, update time left. Here you have an observable which emits every second a value. Use that one and update then the time left. How do I do this? Well, I would require now some way on how to start this interval in the very beginning. So when my SignalStore is actually instantiated, and there is a function for that as well. And that one's called with hooks. And with hooks, again, it's always the same mechanism, the same principle. It gives me access to my store. And it says, you can return me 2 different hooks. I just need one. I say I only want to provide here a function when the component is initialized. So I say here the hook is on init. And then I say, okay, we have here this kind of server-side rendering in place. So that's why we have here this server and also in the component. So I need to move it here as well. We are running here in the injection context. So I can say is if platform is server, inject the platform ID, then I just want to return, don't want to do anything. But if not, if I'm running in the browser, then I want to go to my store and I want to say, hey, look, update time left. You are an Rx method. You run now every second. And I can give you this interval which emits every second. And just to be sure that we start immediately, I also have here a pipe that says start with 0. this is what I want to do. Now my time left is updated every second. And the only thing that I have to change now again is that I need to refactor it inside of my component so that the time left and all the other values are now coming directly from the signal store. Yeah. So here this with hooks, again, it's just a simple object literal that I have to return on init. The other one is obviously on this try. Good. So let me go back to my component. So I can say here, well, this is something I don't need anymore. Everything that the constructor has to do is that it has to connect the IDE with my quiz store, which it has already done. And do I need something else? I don't need the time left. The time started comes now also from my signal store. And the server is also not necessary. So it's now very few code left. The major part is, of course, in my template. And here we have our time left. So I say, okay, here and here and here. You know what's coming. Quiz store, access the time left. Time left is again a deep slice, a deep state. So it's also here a signal. Now I can save it. And if everything works fine, the application is still working. So reload it, countdown runs, answer is also working. Wonderful. I'm done with it. Last thing, and then we are really done, are now the extensions. And here I'm not going to live code them, but I have already prepared them. So I'm just going to copy them and explain the existing code. So extensions means whenever you say you have something very useful in your signal store, which you might want to use in another signal store. So maybe not in the quiz store, but maybe we have, I don't know, a gallery store or I don't know, something else where we, for example, require a countdown feature. So something, what I've done just right now, then I can create an extension. And extensions are extremely simple, are extremely easy to use because you don't have to learn anything new. I just say here, I have a new extension. I call it with countdown. So this, with countdown TS. And as I said, I have already prepared it. And this is the way how it looks like. Let me quickly import all the things and then we can, no, why is this not working? Add all imports. There are some things to import. If I would have been clever, I could also have copied the import statements before, but yeah, we have it already. Good. What I'm doing here is that I just call SignalStore feature and I reuse the same methods that we have already used before with state, with methods. We could also use with computed if I want to, in order to generate some kind of a partial state or as a certain state feature, which I now can use and plug it into my existing quiz store that doesn't have to deal anymore with the countdown logic, for example. So we have here time left, time started, time in seconds. These are state properties which are already here. I don't need to redeclare them in my quiz store. And the same is then also true for those methods. So I say here, I have here some hidden methods. I only expose one. And that one is here the return, the start countdown. So my quiz store can call it just by saying start countdown, time in seconds, and then the countdown starts here internally. Yeah. So how does it look like? Well, I have here my with countdown already. So I say, okay, I go to my quiz store. I say those things, those state properties, I don't need them here anymore. These are part of the countdown feature, so I'm going to remove them. We see immediately we are getting here some errors, obviously, because the state doesn't have those properties. But everything I have to do is that I now just say here, or maybe even before, I have to do it before I actually access them. So I say here with countdown, call the function, and you see all of a sudden the errors go away because time in seconds, all those properties are back again. You can also take a look here. So time in seconds, time started is already there. And we also have here start countdown. And this is now something which is a little bit different in terms of the implementation, because I can't use the hooks anymore. I need to wait for the quiz to tell me what kind of time has been decided for this quiz. So what I have to do here is that I have to remove it here from the with hooks. Don't need them anyway. And I say, as soon as my loading happened, where is it? So here we have this tab. As soon as I have access to this quiz entity, I can already start with the countdown, because then is when I know the time in seconds. So I say here at the very end, after I have patched my state, I just say, okay, look, store, now it's time to start the countdown. And well, you just take the time in seconds directly from the quiz. You already have it. And if everything works fine, that should be it. Yeah. So a little bit of an, as I said before, of a change in terms of implementation. It's not in the hooks. Now it's in the load method. But I think the advantage is obvious. It's very easy to come up with generic functions you can then plug into different stores. That's key here. That's this extensibility. Let's see. Reloading. Countdown works. Wonderful. And this also works. Great. Yeah, and this is the SignalStore feature. This is for me personally, that's for me the main, as I said in the beginning, the advantage why I want to use the SignalStore, or why I favor the SignalStore compared to the global store. Good. Summary. We're already done. So we have seen that the SignalStore embraces this Angular signal. So it is built on top of it, which means we get all these things for free. We have an extension to the signal with required features like patching a signal, like getting nested signals or slices, as they are called with the SignalStore. We have also seen that it is now very easy to combine asynchrony or asynchronicity with signals. That's not very hard anymore. And we can also add rxjs, but in a very elegant way. We can really pick a certain method and say, well, here exactly is where I have a use case for rxjs, and here I want to use it, but not in my other code. Very easy with Rx method. This kind of structured, we've seen with computed, with methods, with states. So there is a structure in our code, and that it is highly extensible is something I have already shown you. Yeah, and we can use it also for global and local state. So the SignalStore also has a config, which I haven't shown you, but it's very easy to say, I want to provide the quiz store as a service provided in root, and then you have global state. Here, I went for the local state. There are some extensions from us as well, from Angular architects. So we have, for example, extension for the DevTools, for the Redux DevTools. So if you want to use the SignalStore and you want to see the state of the SignalStore in your Redux DevTools, then there's an option for it. It's just the with DevTools extension. We also have something for Redux, also something which is very similar to NgRx data and other things as well, which aren't even here listed. So maybe interesting to check it out. Yeah, and if you want, there are some YouTube video from me about the SignalStore. Here you have some links as well. And I would say, yeah, that's it. Thank you very much. And we could now move on to the Q&A.
Okay, so thank you, Rainier, for your awesome presentation. And as you said, we are just jumping to the QA. So I have already the first question from the Alexander.
Yes.
So in SignalStore, if one of the methods wants to use another method defined in the same with methods, it can't unless you create another with methods below and call from there. Is there any better solution?
As far as I know, no. This is exactly the way how you could do it. Theoretically, you could, of course, also create multiple with methods. So if you say you have with methods and you want the second one to inherit those, then this is also possible. But I have to admit, it's not very nice. It doesn't look very nice.
Okay. There is like another question. Probably we should understand it like whether we should use SignalStore for each entity.
Yes, there is an extension with entities, which would actually allow you to manage multiple entities within a SignalStore, but the documentation also very clearly says this is an exception. You should try to have one signal store per entity, if this was the question.
Okay.
And
yeah, do you want to
Mateusz, I mean, I think we can also mention that you are the top contributor to the SignalStore, so you can also join the discussion. I am sure you also have an opinion.
Yeah, but your answer was like perfectly correct, and I would say like nothing to add there. So yeah, as you said. There is another question from Edwin, whether we can access data from global store SignalStore within the features SignalStore.
Yes, of course. So you can just inject the store instance from the global store. It's just an inject store that you have to do, but you can also use multiple feature stores together as well, because the quiz store is just another service, and another store could also just inject the quiz store and use that one as well. So that's not a problem.
Okay. Another question from Adam. In your example, if I only patch the title in the quiz store, then will only the title signal fire, or all of signals originating from the quiz store then?
No, only the title. This is proven. There are a lot of unit tests which exactly cover that part, that only the title fires and not the others.
Mm-hmm. What's patch state? Is it similar to computed?
No, patch state would be similar to signal set and signal update. But the main difference is that patch state says you don't need to provide me the complete value of the signal, only those properties you want to change. Because this is exactly what we have, where when we have demand for the signal store, that we say we have a lot of properties in our signal, and we don't want to clone it all the time. We only want to change this or that other property. And this is why we have the need for a patching function. Okay. It's not computed.
Another question from Marcus. Does the store create signals for properties in the objects? How about performance?
How does the store create signals for properties in the objects? I guess this is about the deep slice, the slices. Mm-hmm. Yeah, so they are first of all created on demand. There is a proxy which runs internally. So if you never require it, for example, if you never require the slice of title, it's never created, this kind of signal. But internally, you of course, you have a normal signal for that. And well, I don't think that there is any performance penalty you have to pay. It's like you have computed for a subproperty.
Yeah. You have mentioned about the testing, so we already have a question like, what's the best resource for learning the test SignalStore?
There is an open GitHub issue where Mateusz and myself have been assigned to. We have to write the documentation. Yeah, so it's not there yet.
Yeah, I was even thinking about this issue when I just was preparing to this meetup, that okay, you will be there
yes.
with this issue and what's going on, whether it's already started. Yeah, so you guys motivated us to.
Yes, exactly. There is also something else. There is this open issue where another colleague presented this the mock SignalStore function, where we are still, I think it's still an open discussion how we are going to do it, especially how the mocking works of the SignalStore. Do we want to bind ourselves to a certain library like Signon.js or Jasmine, or do we provide some generic methods? And I think that's crucial for the testing documentation as well, because you might not only want to test the SignalStore itself, but you very often have use cases where I say, I want to test a component which uses the SignalStore, and I want to mock the component. So and this is what this discussion is all about.
That's right. So another question, when do you prefer to use SignalStore?
To be honest, at the moment, I mean, it's still in developer preview, but it's very stable. I have to say I prefer it always. So I think there are some very rare edge cases where you might want to use the Redux pattern for a very complicated state. There, I would say it would make sense to go with the global store, but only for those selected use cases if you really need it. In terms of the component store, it's clear the SignalStore is the successor. This has been said at NgConf already. And in general, when do I use state management? Well, I would say start with a signal, and when you see your signal grows in size, then you could do this intermediate step with the signal state, which I haven't shown, or just go straight to the SignalStore. I generally, when I have a signal which is large enough, I always go directly to the SignalStore, because you have seen it's just a one-liner. You say SignalStore with state, and that's it. You automatically get patch state and the slices for free. And when you then start adding features after feature, then you can make use of with methods and with computed.
Yeah, and also we can create these custom features as well. Yeah,
Yes.
so we can like decouple our code, reuse it, and it can be global as well. It's just a matter of injection, whether it's in the or the particularly. Okay, there is another question. I have store which uses 5 feature store. Can I override some methods declared in that feature store?
I have a store which uses a feature store. Well, if you have a SignalStore feature like the with countdown, then you can override it. There is currently a PR which discusses this behavior, maybe that we don't want to override it or that we want to have a protection for overriding. As far as I know, it's still in discussion. And I mean, if you have an existing signals, an instance of a SignalStore, I don't think you want to override it. So.
Yeah, we had this concern to just share with you guys when we have been like thinking whether to migrate to the SignalStore, and we have been looking for some weak sides of the SignalStore. So it was like you can create these features when you hide some kind of the logic, and then you put it in your store. And below this feature, you will create like another with methods, which misleading or by accident will just create the method with exactly same name, and this method will be override. Yeah, and right now you will not be notified that you are overriding the method which already exists in your SignalStore or something like that. Yeah, so that's the one thing we have to be cautious when we work with the SignalStore.
Exactly. The other thing, maybe if we already talk about the maybe not so good things, is encapsulation. That always comes up very, very often, that people say, well, what does it mean? Can I now update my SignalStore from everywhere, from every component? At the moment, yes, you can do this. And here I think there is something which is going to change in the SignalStore version 18, that we will get some concept of encapsulation.
Okay, and maybe the last question. What if I want to use SignalStore for shared entities, master data? Should we provide the store globally?
Yes. Yeah.
Okay, so Rainier, that was the last question. We want to extend our heartfelt thanks for you for the fact that you find the time for us. And also we are looking forward to the possibility of having you as a speaker again, or see you somewhere in live on some conferences, what will happen for sure in the future. So thank you one more time.
Thank you very much, Mateusz. And I think we will see each other in Belgrade.
Yeah, so have a nice evening.
Bye. Thanks for listening. Goodbye.